Okay, so we're going to be solving a word problem using the Pythagorean theorem, and the word problem is Tony and Jake are brothers and share a room that is an 8-foot by 15-foot rectangle. One day they got into an argument and decided to split their room with a piece of tape diagonally to keep their sides even. How long does the piece of tape need to be to reach from one corner to the opposite diagonal corner? And so on this chalkboard you can see kind of a diagram of what the room would look like. It's 8 feet by 15 feet, and it's a rectangle. So all of its sides are right angles, and the line that we're looking for is from one diagonal corner, so this guy, over to this one, and we'll call this line X. So from where this last line was drawn, you can kind of see that this makes two triangles from the two halves, and so we're able to take this triangle here and make this right triangle, with this hypotenuse being the length that the tape would be, and our sides are still 15 feet by 8 feet. So now that we have these three variables, we'll be able to plug these into the Pythagorean theorem. So the Pythagorean theorem is a squared plus b squared equals c squared. And looking at this triangle, 8 would be our A, and 15 would be the B, and then C would be X, is what we're solving for. So this is what our numbers look like plugged into the equation, and we can slowly break this down. So 8 squared is 64, so write that right below it. And then we can add 15 squared onto this, which is 225. And then we'll still solve this for x squared. Okay, so this is what we have so far. So 64 plus 225 is 289. And then to continue to solve for x, what you do to one side, you have to do to the other. So to get rid of this square, you'd have to find the square root of x. So you're going to take the square root of 289, which equals 17. And since the room was measured in feet, the diagonal piece of tape would have to be 17 feet to reach from one corner to the opposite diagonal corner. So now we're going to be working in a program called GeoGebra, and I've already set up the rectangle, and in this left toolbar it shows you the points and exactly where they are. So I have points at 0, 0, 0, 8, 15, 0, and 15, 8, and this gives us the exact measurements of what the rectangular room was. So this side AB and BC are distances of 15 feet, and sides BA or AB and CD are 8 feet. And GeoGebra is a lot cleaner than using the little chalkboard or writing it up. And the nice thing is it gives you the distances of the segments. So we can see that our measurements are right so far. We have two, I guess, legs or sides of 8 and two sides of 15. And so when we want to find the distance of the tape, we can click up here and click on this segment between 2 points, and you can click either D to B or A to C, and these will both give you the same diagonal length. So when we click here and click C, this gives you the hypotenuse of either this triangle ADC or this triangle here ABC, and this will give you the exact length for that diagonal line. And in this left toolbar, it actually gives you the exact distance, which would be 17 feet. And so this is a pretty easy tool, just to show students, I guess a cleaner way of finding a diagonal